And this is our final answer. So we're done.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it.
Hello guys, what's up? Welcome back to my YouTube channel, Math-matic TV. So today is another tutorial day. So now I'm going to talk about the integration of indefinite integrals using a Trigonometric substitution. So there are a lot of integrals which can be better evaluated using a substitution. It just depends in the given problem if what attack will be better to use. So for today, let's evaluate indefinite integrals using a Trigonometric substitution. So the formula is when the integrand contains a squared minus x squared, put x is equal to a sine theta. And the second one is a squared plus x squared, so put x equal to a tan theta. And the last one is x squared minus a squared, so substitute x is equal to a secant theta. Also, with the help of a right construction of triangle, the solution may be transformed back into the original algebraic variable. So let's try some problem using a Trigonometric substitution. So let's go. So I will integrate dx over a squared minus x squared raised to 3 halves. So notice that this is look a sine theta substitution, therefore I will put x equal to a sine theta. X squared is equal to a squared sine squared theta, and dx is equal to a times the derivative of sine theta, which is cosine theta. Now I'll plug in this value into the integral. So this is now equal to the integral of dx, which is here, so over a squared minus x squared, which is a squared sine squared theta, raised to 3 halves. And this is equal to the integral of a cosine theta d theta over, I will factor out the a squared times 1 minus sine squared theta raised to 3 halves. Hence, this is equal to integral of a cosine theta d theta over a squared times 1 minus sine squared theta is equal to cosine squared theta. If you remember the identity, sine squared theta plus cosine squared theta is equal to 1. So cosine squared theta is equal to 1 minus sine squared theta. So this is equal to cosine squared theta raised to 3 halves. And this will be cancelled since 2 is distributed to a and cosine theta. So this is equal to integral of a cosine theta d theta over the 3 will be distributed to a and cosine theta, so this will be a cube and cosine cube theta. Hence, this will be cancelled and this will become 2 and 2. So the integral now will be equal to integral of d theta over a squared cosine squared theta. And since 1 over a squared is just a constant, we can put that before the integral sign. So this is equal to 1 over a squared integral of d theta over cosine squared theta. And using the reciprocal identities, cosine squared theta is equal to secant squared theta. So this is equal to 1 over a squared integral of secant squared theta d theta. Now, what is the integral of secant squared theta? If you remember, the derivative of tan theta is secant squared theta. Therefore, the antiderivative of secant squared theta is tan theta. So our answer is equal to 1 over a squared times tan theta plus c. But we're not done yet. We need to get the value of theta. So tan theta is, we need to get the value of tan theta, because tan theta is equal to opposite over adjacent. So we need to construct a triangle to get the value of opposite and adjacent. Okay, since the given equation x equal to a sine theta, so sine theta is equal to x over a. If you remember, sine theta is equal to, or sine is equal to opposite over hypotenuse. So x is the opposite and a is the hypotenuse. So this is the opposite side, which is x, and hypotenuse is a. So the missing side is the adjacent. So let's say this is v. Now let's get the value of v using the Pythagorean formula. So this is equal to a squared equal to v squared plus x squared. So let's get the value of a squared. So let's transpose x squared to the left side if you want to get the value of v squared. So v squared is equal to a squared minus x squared, and v is equal to the square root of a squared minus x squared. Now we have the value of v, which is an adjacent side, and we have the opposite side. Therefore, we can get the value of tan theta, which is equal to opposite over adjacent side. Therefore, tan theta is equal to opposite, which is x, over adjacent, which is square root of a squared minus x squared. Hence, our final answer will be equal to 1 over a squared times tan theta, which is here. So x over the square root of a squared minus x squared plus c. And this is our final answer. Okay, let's proceed to the second example. So let's integrate dx over the square root of 9 plus x squared. So this is a tan theta substitution. So I will put x equal to 3 tan theta. Since a squared is equal to 9, so a is the square root of 9, which is 3. So a tan theta. So x squared is equal to 9 tan theta. And dx is equal to 3 secant squared theta d theta. The derivative of tan theta is secant squared theta. Now I will input this value into the integral. So this is equal to the integral of dx, which is here, 3 secant squared theta d theta over square root of 9 plus x squared, which is here. So 9 tan squared theta. Hence, we can simplify this into integral of 3 secant squared theta d theta over, I will factor the square root of 9. So square root of 9 times square root of 1 plus tan squared theta. And the square root of 9 is equal to 3. It means this will be cancelled. and the integral now will be equal to secant squared theta d theta over square root of 1 plus tan squared theta. And 1 plus tangent squared theta is equal to secant squared theta using the identities. So this is equal to secant squared theta d theta over the square root of secant squared theta, which is equal to secant theta. And this will be cancelled. This will become 1. So the integral now is equal to integral of secant theta d theta, which is equal to ln of secant theta plus tan theta plus c. Now what is the value of secant theta? Okay, we need to draw a triangle to get the value of secant theta. So in triangle, since tan theta is equal to x over 3, which is opposite over adjacent, so the opposite side is x and the adjacent side is 3. The missing side is hypotenuse, which is c. So c squared is equal to adjacent side, which is a squared plus b squared, which is 3. So this will become 9 plus x squared. So c is equal to square root of 9 plus x squared. Now we can get the value of secant theta. Since cosine theta is equal to 1 over secant theta, cosine theta is equal to adjacent side over hypotenuse. Therefore, secant theta will be the reciprocal of cosine theta. So, secant theta will be hypotenuse over adjacent. So now we have a hypotenuse and we have a adjacent. Therefore, we can get the value of secant theta. Now, secant theta is equal to hypotenuse, which is here, so square root of 9 plus x squared over adjacent, which is 3. So now let's input the value of secant theta and tan theta into the answer. So our final answer is equal to ln of secant theta, which is here, square root of 9 plus x squared over 3 plus x over 3, the value of tan theta, then plus c. Hence, this is our final answer. Actually, we can simplify this into we can combine square root of 9 plus x squared plus x, since they have the same denominator. Well, this is correct also. So let's proceed to the last example. Now let's proceed to the last example, which is integral of dx over x squared times square root of x squared minus 1. Now this is look a secant theta substitution. So I'll put x equal to secant theta. So since a squared is 1, the square root of 1 is still 1. So the same as x is equal to secant theta. And x squared is equal to secant squared theta. Dx is equal to the derivative of secant theta, which is secant theta tan theta d theta. Now I will input this value into the integral. So this is equal to integral of dx, which is here, over x squared, which is secant squared theta, times square root of secant squared theta minus 1. And notice that secant theta will be cancelled. this will become 1. So the integral will be equal to integral of tan theta d theta over secant theta times square root of secant squared theta minus 1. And secant squared theta minus 1 is equal to tan squared theta. So this is equal now to integral of tan theta d theta over secant theta times square root of tan squared theta, which is equal to tan theta d theta over secant squared theta. The square root of tan squared theta is tan theta. I'm sorry, this is secant theta only, since secant squared theta is already cancelled. Hence, tan theta will also cancel. Now, the integral will be equal to integral of d theta over secant theta, which is equal to the integral of cosine theta d theta. And now, what is the integral of cos theta? The integral of cos theta is sine theta. Since the derivative of sine theta is cos theta, therefore the antiderivative of cos theta is sine theta. So our final answer is equal to sine theta plus c. But again, we're not done yet because we need to get the value of sine theta. So let's use this given equation, which is x is equal to secant theta. Since x equal to secant theta, so cos theta is equal to 1 over x. Since secant theta is the reciprocal of cos theta, so cos theta is equal to adjacent over hypotenuse. So 1 is the adjacent side and x is the hypotenuse side. So let's construct a right triangle. So the adjacent is 1 and the hypotenuse is x. Our missing side is the opposite. So this is the missing side. So let's find the value of the opposite side, which is, let's say this is v. So using the Pythagorean formula, x squared is equal to 1 plus v squared. And if you want to get the value of v squared, transpose 1 into the left side, which is x squared minus 1 equal to v squared. And v is equal to the square root of x squared minus 1. Now we have the value of the opposite side, so we can get the value of sine theta, because sine theta is equal to opposite side over hypotenuse, because we have already the value of hypotenuse, which is x. So now let's get the value of sine theta. So sine theta is equal to opposite over hypotenuse. Our opposite side is v, which is x squared minus the square root of x squared minus 1 over hypotenuse, which is x. Hence our final answer will be equal to, okay, let's plug in the value of sine theta into the answer to get the final answer. So our final answer will be square root of x squared minus 1 over x plus c. And this is our final answer. So we're done. Alright, that's all for today, guys. Thank you so much for watching, and please share your thoughts about it by commenting below. And if you learned something today, please give this video a thumbs up. Also, if you want to see the other videos, link in the description below. And please don't forget to subscribe and click the notification bell. Stay tuned and see you on my next video. Thanks and God bless.
I have a dream, that's all I need. I'll make it happen with some work and belief. Know what I want, so I'll take it on. I've made mistakes, but mistakes make you strong.